All right, we're going to hand over to our next speaker. And you've seen our next speaker before, hopefully, as well. Ashley Davis is here to tell us a little bit about how you can start sharing code between TypeScript projects. Ashley, are you there?
Thanks, Kevin. Hi, everyone. Really good, it's great to be talking for BrizJS again. I always love it, always have a lot of fun. Thanks, Steve. That was a really awesome meta talk. I really enjoyed it. Who doesn't love geeking out with friends? It did make me think that I'm probably going to be breaking most of your guidelines in this talk tonight, so sorry about that. And I kind of wish I'd had a bit more of a pun for a title of my talk as well, but I'm terrible with that kind of thing. So anyway, I would encourage anyone to come and talk for BrizJS. It's a really rewarding experience. It's really changed a lot of things for me. You know, talking at a conference can be quite daunting, but talking for BrizJS is really easy. You don't need to do a lot of preparation, and we're really welcoming. So, you know, come and talk for BrizJS. We'd love to have you. Please submit your talks. My tips actually for talking are practice live streaming. That's what I did. Basically, just get on Twitch, start doing some coding, talk about it. You know, even if you stuff up, no one cares. Probably no one's going to watch. No one much watched me. But it does help you get better handle on being able to code and talk at the same time. And also for handling those disasters that naturally do happen when you're doing live coding or giving demos. So just jump on Twitch, do some live streaming. If it doesn't work out, you can always delete it. So anyway, as Kevin said, my name is Ashley Davis. I'm the author of Bootstrapping Microservices. And I'm going to talk to you tonight. I'm going to show you tonight how to share TypeScript code between your projects. I hope everyone's doing okay in the various lockdowns and staying safe. I've just had my first vaccination, very much looking for my second, and hopefully be able to do some traveling again at some point. So I don't have any slides tonight. So that's the first thing, or already flashy animations or anything like that. I'm actually just going to walk you through some code examples that I created earlier and hopefully teach you something useful. You can find the code itself on GitHub, and you can follow along as I'm doing this if you like, or you can follow along later watching this replay on YouTube. I also have a blog post about this coming up as well. So if you want to get more details, get on my Twitter, AshleyDavis75, and wait for an update. I will be doing a blog post on this in the coming weeks, and I'll be keen to share that with everyone. Now, before we get into it, I just want to do a bit of a shout out for the awesome company that I'm contracting with, Schedulo. They are hiring developers. A really nice bunch of people. Go to schedulo.com/careers, click on see all job listings. There's a few here at the moment. If you've got to choose the right department, depending on what you're interested in, somewhere here, product development. But there's heaps more jobs going to be listed on here in the coming months as well. So please bookmark this careers page, schedulo.com/careers, and you'll find some interesting stuff here in the future. So let's talk about TypeScript. Now, how do we share code between TypeScript projects? There's a few different ways we can do this, right? And the one that you're probably thinking of, the one that you probably heard of before, is publishing like an NPM library. So this is the NPM package repository here. You can take a TypeScript project, compile it to JavaScript, and then publish it on here along with the types. And then you can pull that library, that package, into any other kind of TypeScript project that you want and use it. I'm just going to show you one that I did called DataForge. So DataForge is a TypeScript project. It's been published on NPM. It's public. Anyone can use this. And so this is the kind of, I guess, the default way really of sharing code in our community is through NPM. We can do this publicly or privately. So you can have a private account. You might have to pay for that. But you can have a private account on NPM, and you can publish your packages just for your team if you want to. Another way of doing it as well, which might be appealing, is you can literally just publish your compiled JavaScript code on GitHub. And again, either you can do that publicly or privately. But then you can actually NPM install it. So it's like, it's an alternative to actually publishing an NPM package is to just put it on GitHub. So these are the easy ways, really, and the kind of default ways for sharing TypeScript code. I'm going to go a little bit deeper than this tonight. So, most of the times you can probably get by with NPM, but I actually come from a different world. I come from a background working in C++ originally, and then C#. And the way that we would share our code libraries is that we'd have it in a separate project, we'd compile it, and we'd share the lib file or the DLL or whatever it is in the language that you're working in. And I was after a similar way of doing that kind of thing with TypeScript, where I didn't have to go through this step of publishing it to NPM or GitHub in order to share it, say, with another local project on my computer or something like that. Now, the good news is we can do this with TypeScript, and with TypeScript version 3 and above, it has support for a feature called project references. So here is the doc for that here. You can just Google project references TypeScript and you'll find this pretty quick. Pretty good bit of doco here. There's not much to it. You can read through this pretty quickly, but I'm just going to give you a demo of how this works, and then I'm going to move on to some more advanced stuff that really isn't covered by project references. I have got 3 examples that you can find on GitHub, and I'm going to clone it from scratch tonight. Fingers crossed it all works, but if not, I've got a backup. So go to my GitHub if you want to grab this for yourself now or later. GitHub.com/Ashley Davis, and then find the repo sharing TypeScript code libraries. Now, there's 3 examples under this. There's a basic Node.js example. So that's a real simple bare bones example that doesn't have anything special in it, but it's just a necessary starting point. It's just a building block. So we're going to quickly have a look at that before we move on to the more advanced examples, which are the microservices example, which shows you how to share TypeScript code between Docker images or microservices, and the microservices and front-end example, which shows you how to share code between your backend microservices and your front-end UI. Now, bear in mind as well that this can be a very flexible approach. So whether you're using like a mono-repo or a meta-repo, you can use these techniques to help you. And it's very, very flexible the way you structure this. You can structure your folders and your files pretty much any way you like. I've got a particular setup that I'm showing you tonight, but you can do it any way you want, basically. Anyway, another thing you can do here in this repo is if you drill down to any one of these sub examples, I've got some nice diagrams here that kind of show you the structure of the project and the file system for each of the examples. So I'm going to be actually taking you through those files in a moment, but come back and have a look at this later if you want to sort of get clearer on how it works. I'm going to clone this from scratch. So if I go to click here, copy the repo URL, go to my command line. I'm just going to do a git clone, get this locally. Cool. We have code. So I'm just going to change. I'm using Windows here, but you can do this on Linux. You can do this on Mac OS. It's much the same. So in here, I have got my examples. I'm actually just going to jump in and just do some npm installs to get dependencies, just so that we don't have to do that like as I'm going, basically. So I'm going to open another terminal here. And I'll just go down to the microservice, because this is another one that this just takes a little while to install the dependencies. So I'll get them installing while we're waiting. And this one is ready to go, which is good. So I've drilled down to, let's just go back one directory here. I've drilled down to the Node.js example here, and I'm just going to open this in Visual Studio Code. So what we're going to see here is a fairly simple Node.js project. There's nothing special about this. In fact, it's just a hello world application. So what we've got here in the root directory, we've got basically a Node.js project. Let's get rid of that. We've got a Node.js project, and we've got a libs directory. The libs directory contains our shared libraries. There's only one in there, my library. You could have multiple other libraries in there. It doesn't matter. To keep this simple, I've only got one. So that's a fairly standard, TypeScript Node.js project. And then my project is the same. It's got a package.json. Both of these have got package.json files, which is the metadata for Node.js. Both of these has the tsconfig file, which is the configuration file for TypeScript. If we have a quick look at the code for the library, super simple. It's just a function called showMessage, which prints hello world. Nothing too exciting there. And the code for the project just calls that function. It imports it from the shared library. Now, the way this fits together, the way this works is because in the tsconfig, if we scroll down to the bottom, we've got this section here called references. And so it's saying, I want to reference this library here. And this is what allows us to reference some TypeScript code outside of our root directory. So you can see here that it's basically the ... is going outside the root directory and into the library. Now, let's see this in action. So now to compile this from TypeScript code into JavaScript code, I need to run the TypeScript compiler. Now, I'm running all this under Node.js. I'm actually running a fairly recent version of Node 14. Normally, when we're compiling a TypeScript program, we would just run npx tsc, the TypeScript compiler, or I've got it set up in my package.json file that I can run npm run build. And you can see that that's just running the TypeScript compiler, but it's actually got an extra option on the end here. So we can do that manually as well. This is what's enabling the TypeScript compiler, this build argument here. That's what it's enabling it to basically pull in the project references. So what it's doing is it's not just compiling, the directory we're in. It's not just compiling my project, but it's also looking at what you've got in your project references, and it's going and compiling each one of those as well. So this is the first part of it. So once you've run that, we have in our my project, we have a dist directory. Hopefully everyone can see this. We've got a dist directory, and we've got a compiled JavaScript file, which has got our call basically into our library function here. And if we look at the generated JavaScript code under the dist directory for my library, you can see that we've got the compiled code here for the library. There's nothing too exciting here. It's really just a little bit of a helper that can connect multiple projects, multiple TypeScript projects, and compile them all when you use this build argument that we used here on the command line. And like I said, I have encoded this in the package.json file. So if we just find that for my project, you can see here the build script is just set to that command TypeScript compiler -- build. So again, nothing too exciting there, but we have to cover this before we move on to the slightly more advanced example, which we'll do now. So we're going to go back a bit into the root directory of the repo. And what we're going to look at now is this microservices example. And I'm going to open Visual Studio Code on this project, and we'll have a look at it. It's basically the same. It's basically the same as that other project we just looked at, except we're adding a Docker image, a Docker file into the equation. So you'll notice we've got the same folders here. We've got my project. Under our shared libraries, we've got my library. My library, it's just a code library. It doesn't need a Docker image, so there's no Docker file in here. But if we open up my project, you will see the Docker file is here. Now, this is where it starts to get a little bit more complicated. And the main problem here, is that we want to compile all of our code, including our shared libraries, but then we want to bundle all the compiled code in a way that we can easily include it in our Docker image. Easier said than done, but hopefully you'll like my solution that I've got. So one thing here to notice is that the Docker file and the Docker ignore file are at separate levels in the directory structure. So the Docker ignore file is in the root directory, and the Docker file is down in the my project directory. Now, just bear in mind here that even though we've only got one project here, we could have multiple separate folders here for other microservices. We could also have multiple other folders here for other libraries. So it's a basic, simple setup. So it's just got one microservice. The structure is designed to have more added to it. They're all built against the context. So the context that we're sending to the Docker daemon is this kind of root directory here. So that means the Docker daemon has access to the code for my project and also for my library. And it has access to the code for anything else that we put in here as well. So that's kind of what makes this extensible. But because it's run at the context of, or the context for the Docker image is set to the root directory of this project, that's where we put the Docker ignore file. And we're doing a few things here just to keep from sending too many files into Docker. One is we're basically saying for any subfolders that have node modules, we're going to ignore those. We're not going to send them to Docker because we're going to do the npm install within Docker. We're not going to send our .git directory because that's a big no-no. If you've got a big history in your repo, you don't want to send that entire history to your Docker daemon that doesn't need to know about all that stuff. And then your output directories, as well as this kind of generated build file here, we don't want to include that. And we don't want to include any of this stuff for any of the subdirectories. So let's have a dive down into the Dockerfile. Let's just get a little bit more room here so we can see what we're doing. So I'm just going to zoom out a little bit just so you can kind of see this whole thing in its entirety, even though you won't be able to read it at this level. I just want to give you sort of a bird's eye view of the Dockerfile here. So you've got the whole Dockerfile. Now it's broken down into two parts. So the first part is the builder part. So that's what's doing all the building of the TypeScript code to JavaScript, and it's doing the bundling and it's preparing dependencies. And then all we're doing for the prod image, which is this last bit here, which I'll zoom in on now so you can see. So this is the sort of the Docker build phase here that builds the prod image. The main thing it's really doing here is it's just copying. It's just copying whatever you've built, whatever you've copied to this build directory under my project. It's just copying that into the Docker image. So it's not much happening here really. And then it's actually starting. It's running npm start, which is configured in package.json to actually start this application under Node. So coming back to how this is all built together, let's look at the first half of this equation here. There's not much of this. I just want you to get the gist of this really. I don't really want you to understand everything about how this works, but just see here that we're gonna build this against the context of the entire project here, and we're copying everything over. So that includes my project. It includes my library. It's going to include any other microservices you add to this. It's going to include any other libraries you add to this. But if you are worried that you're copying too much and you want to kind of optimize that, you can break this out into multiple copy statements, and you could copy, one library or another, or you could copy, one microservice against another. It doesn't matter. I'm not sure it matters unless you've got huge microservices or huge libraries, which you probably shouldn't. So it's copying everything over to the Docker daemon there. And then we're running an npm install. So this is basically what's going to get us our TypeScript compiler and all our dependencies. We're running the build script in the package.json. Let's do a quick aside and have a look at that. So that's defined here. So what you can see here is that it's running TypeScript with that build argument we looked at a moment ago. So that's what's going to build like the current project, the current microservice, and it's going to like fan out and compile all the shared libraries as well. And then it's got this other thing here called TS project bundle, which is basically like a little program that's going to pull together all your compiled files, all the compiled JavaScript for everything that you're referencing in your project references, and it's going to copy that to this output directory, the build directory. I created this. I couldn't find anything in TypeScript that could do this, so I had to create this. But it's very simple code, and I'll show you where that lives on npm in just a moment. But anyway, let's just cover the rest of this Dockerfile first. So now, after we've done our build, so we've run TypeScript, we've bundled together all our compiled JavaScript code. We're now setting our working directory into the build directory, which is where all that bundled JavaScript code has gone. And we're going to do an npm install to get this handy little program called Recursive Install. And this is what, again, another thing that makes this solution kind of extensible to more libraries and more microservices is that we're not just running a normal npm install, we're recursively installing dependencies for all our projects that are in all the subdirectories. And bear in mind that we're only doing this for our build directory. So it's very concise. We're targeting exactly what we want to target here. And we're only installing the production dependencies. That's what that production flag does. So at this point here, we've compiled our TypeScript code. We've bundled it together. We've installed the dependencies for the production code. And then all that's left to do here is to copy that to the production image. So that's what ties this whole thing together here. So hopefully that's been interesting. I'm not gonna. I could build this and run it, but there's no point. If you've seen my talks before, and you can find them on YouTube, you can see a few other examples of me running Docker and sometimes failing. So I'm not going to worry too much about that tonight. The only slight problem with this approach really is this copy. But like I said, if you feel like this is copying too much, just remember that this is only copying into your your build stage image. It's not copying everything into your production image. If you're worried about the performance of the build stage, you can refine this. You can kind of restrict it to just the things you want to copy. But ultimately, what we're doing here with the compilation process and also with the bundling and the recursive install, we're only kind of getting the stuff that we need in production and putting that into our final production image, which is the last stage down here. So now we have one more example to look at, and then I'm done. So this is the front end example, which the npm install for this would have taken a little while. That's why I started it off earlier. But I don't need that extra terminal, so I'll just close that. But let's go back to the root directory of the repo here. We're going to look at this microservices and front end example now. Now again, it's just like the previous examples. I've added a little bit more into it. We've upped the ante a little bit. I'm just going to run Visual Studio Code here. We'll have a look at this project structure, and then we'll build our front end. So this is a really simple front end based on TypeScript, based on React, using Parcel for the bundler. We've got the backend for it is under this backend directory here. And what we have here is just my project. So it's just the one we just looked at. It's just like the Hello World project. It's nothing exciting. But it's the same as before. The Dockerfile is basically the same, except some of the paths have been changed a little bit because I've put this in a backend directory now. Now, we could put other microservices in this directory, so it can be a multi-microservice backend if you need it to be. But for purposes of simple example, I've just got the one project there. We've got the front-end project here, so that's what we're going to look at in just a moment. Before we look at that, we've got the libs directory with my library that you've seen before. So the Hello World, my library. It doesn't do much, but it's just an example of a shared library that we're going to share from the back end to the front end. And you could put as many other libraries in this directory as you want. Now, this works really simply with Parcel. I did try this first up. I did try this using what's it called? Create React app, or what it is, that program that you can use to create your boilerplate React app. I couldn't get project references to work with that. Something to do with the configuration of TypeScript there prohibited that. But I prefer Parcel anyway, and I use Parcel myself now. I haven't tried this with Webpack. I imagine you could get this fairly easily working with Webpack as well. So in the front end directory, we have got an index file. So this is the front end. It's really simple. It's just got a stub where we're going to put our React UI, and it's pulling in the TypeScript file. Now, the cool thing about Parcel is you just give it like a reference to this file, and it knows how to compile TypeScript code. So it's like it's totally zero configuration. That's why I love Parcel. I just didn't have to do anything to set it up. It just understands like the common asset types that you'd want to use in web development. Now, in the tsconfig for this front end, again, we see the project reference. So we're referencing for our front end, we're referencing my library. And we could put as many other libraries here as we like. Now, just looking at the code, so this is just a really basic stub React application, but we're pulling in the show message function from our library, and then we're using that, we're embedding the string that returns in our UI. Pretty simple stuff. If we look at package.json, you can see what we have to do to build this. I've got a compile script here, and that's doing the TypeScript with the build argument that we've seen a couple of times already. And then the actual build command, which is the one that actually going to compile our single page application into a bundle that's ready to be a published static website. We're running that npm run compile. And then what we're doing is we're running Parcel build. We're pointing at our index.html, and we're telling it to go to the output directory. So this is like really simple. There's hardly anything new here. Like if you already know React and TypeScript and Parcel, which you might not. So if you don't, it could all seem pretty complicated. But if you know those things already, you can hopefully see that what I'm adding on here is nothing complicated. At least nothing complicated compared to what we just did with Docker. So this is kind of the easy part really after Docker. But now I can run Now I have to go into my front end directory here, but I can do an Npm Run Build against this. It's going to do the compile, which is doing the TypeScript compile with using that build argument. This parcel takes a little bit of time. It's a small web page, so it doesn't take much time at all, really, but it takes a little bit of time the first time you run it, and then it's all cached, so it's really fast after that. But you can see here it's output the files that it's generated. We've got a HTML file, and importantly, we've got a JavaScript file to include in the HTML file. So this is the compiled TypeScript code, including the bundled version of our library. That we, and bear in mind, this is a library that we've shared into our microservice, and we've now just successfully shared it into our front end code. So let's have a look at what that code looks like. I guarantee you it's going to be unreadable. I was due to the outdir here. Basically, we're putting it to this outdir here. So this is the code that's been generated. You can see an almost unreadable HTML file. Actually, it's not too bad because there's not much in it, but you can see our index.html has been rewired to kind of use our JavaScript file that was compiled using Parcel. And if we look at that JavaScript file, this is where it gets unreadable. This is a minified, sort of uglified mess of JavaScript code. But just to show you that the hello world function is in there somewhere. In fact, I'll just show you what the latest version of the hello world function looks like, because originally, in the original example we looked at, it was a little bit different to this. But here you can see it's just a function that returns a string, and it's returning hello world. And we're just printing that out into our UI. So again, examples aren't too compelling there, but I've done some really cool stuff with this. But what I want to search for here is hello world. So there you go. You can see that our hello world function has been sort of minified down to this function called E in the output JavaScript code. So Parcel's done that for us. It's automatically compiled our TypeScript code according to our TypeScript configuration. It's automatically, magically pulled in our project reference to my library, and it's pulled in, compiled in this hello world function that we can now use in our front end. So I think that's about it. I will just return to the repo. So if you enjoyed that and you want to try it out for yourself, please come to my GitHub, Ashley Davis at GitHub, sharing TypeScript code libraries. Come and grab it for yourself. Do what I've just done. Watch it on replay if you want to catch up on it. Catch me on Twitter, and you will find that I do have a blog post coming out on this topic in the near future. Thanks for listening.
Thank you so much. That's awesome. We'll get through a few questions as well. Cool. First one that's in here is, does the I think this one was early in the piece. Does the compiler keep the built projects in the same place or bring them together into the one project space?
No, so that was the piece that was missing, right? And I'll just quickly share screen again and show you where that was. So unfortunately, it's a little bit dumb, right? It will, how does it work? So basically, when you ask it to compile your project, it just looks at the project references in the tsconfig, it iterates them, it builds them as well. But that's all it does, which is like, it's only part of the solution, really. And, kudos for them for adding that, but it should really bring all the code together, shouldn't it? There should be like, I'm really itching for TypeScript to have a great bundler built in. But that's why I had to create this thing, TS project bundle. So I didn't actually come here. I was going to show this, but I didn't come here. This is like super simple. You can install it. I'll show you how it runs here. Now, where did I have that? I think it was in the package file for my project. Yeah, so the build process for my project, for my microservice, or for whatever project where I'm bringing in the shared TypeScript libraries, I'm doing that build that builds the current project and all the dependencies. But then I'm running my little command line tool here, TS project bundle, which is basically just going to load. All it does is it loads this tsconfig file. We're in the wrong one here, but you get the picture. It just loads the tsconfig file for the project that you're building, and it just kind of passes the JSON and iterates over this. It figures out where you keep your code. So normally in your tsconfig, you've got like an appdir. So it knows where for each project, each dependency, where it gets compiled to, and it just does like a copy, a file copy. So that's TS Project Bundle, something I had to build for myself. So that's an interesting little project if anyone's interested in having a look at that and extending it for themselves as well. I would not be surprised if this is included in TypeScript at some point in the future, because it just seems such an omission for it not to be able to to have this great feature that does all these different projects for you at once, but then not to gather it together. So it's also possible that I've missed something as well. So if anyone out there knows a better way of doing this, like, I'm all ears. Please tell me.
Yeah, for sure. That's really interesting. And I guess that answers the next question as well. I think it's part of a little misunderstanding. It's like, is it going to dynamically pull in external projects to compile, or do you need to get them locally first? So it only goes on local paths, right?
Yeah, that's right. And it's not that intelligent. So I don't think there's anything dynamically about it. It's just literally, it feels like it's going to walk each of the projects and run your TypeScript compile on them. So you don't have to do it for each project. It compiles them for you. But I don't think there's anything particularly dynamic about it. Like when you come to run the project, so normally when you run a TypeScript project, unless you're doing it in development, I run TypeScript code directly using TS Node. But when you're running it in production, you're always going to be running compiled JavaScript code. I'm not aware of any systems that would compile TypeScript code on the fly either in a production system. So it's typically not what you do. It's you want it to be in JavaScript for the performance and not have to do that compile phase in production.
Absolutely. And then the next one is, how does this work between projects with nested TypeScript projects? So I guess it's recursive.
I don't use nested TypeScript projects, so I don't know. To be honest, if you'd said to me use nested TypeScript projects, I'd say, like, that sounds really dangerous. Like,
yeah,
there's bound to be some weird kind of edge cases and difficult to configure things there. So I haven't used nested TypeScript projects. It might work fine. In fact, I'm kind of curious to try that now.
Cool. Well, the next one's very simple. What version was external references introduced?
If I didn't say, it was version 3.
There you go. What would you say the benefits are over linking in an NPM module with NPM link that points to a local copy of your package?
That's certainly something I use all the time for my published NPM packages. Like, in fact, I learned about that a year or two ago, I think, but I was doing NPM stuff for years before that. So I don't know how I ever got by doing development for like NPM packages without NPM link. It's so like invaluable that if you want to publish something on NPM and you want to test it, like the thing I used to do was I'd like publish an update and then kind of pull it in to test it. And of course, that's a horrible way to work. And sometimes I still that's like, I still have this mentality like built into my brain, baked in basically, that I think, oh, I've got to publish this thing to test it. But then I'm like, NPM link is my savior. So NPM link is fantastic. I use it all the time. There are plenty of times though when you don't want to publish like a package to NPM, like I build microservice applications and I want to share code between microservices, and like publishing to anywhere, even if it's private publishing, because you don't want to show other people, your proprietary code or whatever. It's just an unnecessary step, right? That makes development more difficult. And so, like if you're using like a mono-repo or a meta-repo, if you've got multiple projects, just configured locally, different repos configured locally on your computer, you can share code libraries without having to publish. It's just such a time saver for those times when there's no benefit to publishing.
Yeah, absolutely. Yeah, if you don't need the overhead, makes sense. We got one in here. What is the difference between references to include in TS config? For example, using include, and then there's a globbing pattern for /*/.ts and libs/data.ts.
I can't even visualize what that looks like.
Great call. Let me point that. Hang on. Let's peek behind the curtain. Share. This will work. There we go.
Oh, right. So
dig in.
that's a separate TypeScript compiler setting, and that's telling it. I'm not entirely sure as well. You'd have to go and read the docs to be sure on this, but I think it's just telling it, what source files to include to compile into your project, and like where to find them in your directory structure. And the globbing stuff is all about, get me all JavaScript files, or sorry, get me all TypeScript files or TSX files or whatever. So I think that's just telling you what you want included in this project. But project references allows you to link to whole other projects that have their own kind of, include directives.
Their own configs and everything else. Yeah, absolutely. Probably a little bit more flexible. Yeah, so this is the globbing pattern of where it can find all your source code. So, for example, I think if you were to point multiple patterns at include for other projects, you'd end up with namespace conflicting and stuff like that. I think too, like you'd end up defining something in one project that would probably reference the same thing as another in another project. Yeah. So I think your reference is the equivalent of that, so to speak, to be able to reuse.
You need references when you start getting this message from the TypeScript compiler that says you're trying to include code like outside your project's directory. If you've ever had that error message or that warning or whatever it is, you're like, oh, but I wanted to use my code from over there. And like, that's where you need project references. That's the perfect example. So if you've had that experience where you had that error message, you know how to deal with it now, hopefully.
Nice. All right. That's fantastic. Woo! For all of them. Thanks very much, mate. I really appreciate it. And
Thanks, Kevin.
I'm sure everyone out there has gleaned something else that's interesting to them now as well. So that's fantastic.
Sweet.
Thank you.
Always love it. Thanks, mate. Bye-bye.
All right.